At the heart of every product, every innovation, lies a process. This isn't about algorithms or code, it's about the fundamental steps, the actions taken to transform an idea into reality. We call these technological processes, and they are the invisible engines driving our modern world. From the food we eat to the phones in our pockets, each relies on a carefully orchestrated sequence of operations. Understanding these processes is key to unlocking efficiency, driving innovation, and ultimately building a better future. Whether it's a single specialized task or a complex web of interconnected operations, each process plays a vital role. By delving into the different types of technological processes, we can begin to appreciate their significance in shaping our world. In the vast landscape of manufacturing and production, technological processes are categorized by their degree of unification. This classification helps us understand the complexity and interconnectedness of different operations. By grouping similar processes together, we can streamline production, optimize resource allocation, and ultimately create better products. This exploration into the world of technological processes will shed light on three key types: single, typical, and group processes. Each category possesses unique characteristics, purposes, and applications, contributing to the intricate tapestry of modern production. Single technological processes represent the building blocks of production. These processes are characterized by their focus on a single specific operation. Think of it like a specialized tool designed for one specific purpose. An example of this is the process of cutting metal sheets into specific shapes using a laser cutter. This process involves a single machine and a defined set of parameters to achieve the desired outcome. Another example is the process of sewing a button onto a garment in the fashion industry. The purpose of single technological processes is to achieve precision and repeatability in a specific task. They are often highly automated and rely on specialized equipment. The detailing of a single process involves defining the exact parameters, tools, and steps required to achieve the desired outcome consistently. These processes, while seemingly simple, are crucial for maintaining quality and consistency in mass production. Each cut, weld, or stitch contributes to the final product, highlighting the importance of mastering these fundamental operations. As production scales, we encounter processes that share similarities across different products or industries. These are known as typical technological processes, representing standardized sequences of operations applicable to a range of products. Imagine a recipe that can be adapted to create various dishes by changing a few ingredients. One example is the process of painting a car, which shares similarities with painting furniture or even painting a house. The core steps of surface preparation, paint application, and drying remain consistent despite the different end products. Another example is the process of packaging goods, which often involves similar steps like wrapping, labeling, and boxing, regardless of the product inside. Typical processes offer a framework for efficiency. By identifying and standardizing common operations, companies can streamline production, reduce errors, and optimize resource allocation. The detailing of a typical process involves outlining the general steps, equipment, and quality control measures applicable to a range of products. These processes are instrumental in achieving economies of scale. By leveraging commonalities, manufacturers can reduce production costs and increase output without compromising quality. At the highest level of complexity, we have group technological processes. These processes are formed by combining multiple single or typical processes into an interconnected network. Think of it as an orchestra, where each instrument plays a specific part to create a harmonious symphony. The assembly of a smartphone is a prime example of a group process. It involves numerous single processes, such as assembling the circuit board, attaching the screen, and installing the battery. Each of these processes, in turn, may be composed of even smaller, more specialized operations. Group processes are essential for creating complex products that require a high level of coordination and integration. The detailing of these processes is extensive, involving detailed flowcharts, process maps and documentation outlining the sequence, dependencies and quality control measures for each stage. The success of a group process relies on seamless communication and coordination between different teams and departments. Any bottleneck or delay in one process can have a ripple effect, impacting the entire production line. However, when executed effectively, group processes enable the creation of highly sophisticated products that meet the demands of our technologically advanced world.